So we now see the electroplating of the two things. So one is by using the nickel and the other one is by using silver. So first thing is, you can see the figure is going to be the same. Only thing is that either in one of the case it will be the silver block will be here as anode, and in the second case it will be having nickel, block of nickel as the thing. Over here, the in case of nickel, it will be like NiSO4, which is going to be there is the electrolyte, whereas in this case it will be silver argentocyanide, that is NaAgCN twice. It's silver argentocyanide, sodium argentocyanide. Okay, silver and argento is the same, so that's a mistake I did. Also gets sodium argentocyanide. Okay, it's sodium argentocyanide is used as electrolyte in case of silver. So first thing is, the electrolyte will be aqueous solution of nickel sulfate, or it will be so I'll just take the nickel first. So let's take the nickel electroplating first. So nature of electrode will be cathode will be cleaned article or to be electroplated. So the article to be electroplated will be cathode, and anode will be a block of pure block of nickel. Electrode reaction will be, of course, NiSO4 will give you Ni2 plus SO4 2 minus plus H2O will give you H plus and OH minus. At the cathode, the reaction will be Ni will be at cathode. Ni will be coming over here and getting deposited over here. So Ni2 plus electrons will give you Ni, which will be coming over here. So Ni moves towards the cathode and are discharged as neutral Ni atoms by gain of electrons. Thus nickel is deposited on the article as cathode, and reaction at anode, Ni is going to give up 2 electrons and become Ni2 plus, and this so SO4 and OH are just going to be spectators to the anode, but neither of them are discharged. Instead, the nickel anode loses electrons to give Ni2 plus solution ion in the solution, and hence anode diminishes in mass and product and anode will be nil. So that about the nickel coated article. So if I want to coat an article with nickel, I'll take the anode. So highlight will be the electrolyte will be nickel sulfate, anode will be nickel, it will be connected to the and the negative terminal will be connected to the article to be coated. Similar is the case for silver coating. So if I'm coating anything with silver, I'm going to take silver sodium argentocyanide. So sodium argentocyanide is migration of Ag and are from above complex salt solution is slow compared to the sodium silver nitrate. Now, if I am taking silver nitrate instead of sodium argentocyanide, then the deposition will be uneven. So, and because of the silver nitrate over there, so the silver nitrate, the deposition will be uneven, and that's why sodium argentocyanide is taken, because the deposition in this case is slow, and the dissociation is slow, and hence the deposition of silver on the article is even and more distributed properly. So that's why we are taking as sodium argentocyanide and not silver nitrate as the electrolyte. Nature wise, the cathode will be cleaned article to be electroplated, anode will be pure block of plate or block of silver metal. Dissociation mein NaAgCN2 will give you Na plus, Ag plus and Cn minus, and H2O will give you H plus and OH minus. So Ag plus is going to give, Ag being the last in the electrochemical series, so it will get discharged first, so it will be discharged at the cathode and hence it will be coated on the cathode particle. So Ag 1 minus will give you Ag, and Cn minus and On minus are just going to be Ag plus 1 electron will give you Ag deposited on the cathode as neutral Ag atoms, and thus silver is deposited at the article at the cathode, and anode Ag minus 1 electron will give you Ag 1 plus and Cn 1 minus and OH 1 minus ions migrate to the anode, but neither are discharged. Instead, the silver anode is going to lose electrons to give Ag plus 1 ions in solution, and hence the anode is going to diminish in mass. So product formed at the anode will be nil. So that was about electroplating. The next kind of the example is of electro refining. So electro refining is a similar kind of process. So in this case, exactly the things remain the same, but the anode and cathode are going to be slightly different. So what we do is, in case of this part, the anode will be a impure. So this one over here will be impure, let's say copper, and this will be a thin sheet of, this is pure copper. So this is just pure copper, like thin wire. A thin wire of pure copper will be there, and this will be, of course, this part will be CuSO4. So what will happen is the Cu from here will start depositing on this, and finally all the impurities of this are going to be left out as the anode mud, and the whole thing over here becomes a pure copper metal. So slowly and steadily all the ions of copper are going to come to the copper sulfate, and from here it is going to this or deposited on the thin wire of which is present as the cathode. So electro refining is the process. This is called as electro refining. So electro refining is a process by which metals containing impurities are purified electrolytically to give a pure metal. The term refining means to make pure, and the method employed to make the pure metal by electrolysis. That's why it is electro refining. So electro refining of copper, you can see over here the electrolyte is aqueous solution of copper sulfate acidified, the same as the inert electrode wala. So the same process over here. The nature of electrode will be copper will be thin sheet of copper. It will be a thin sheet of copper as a cathode, and a impure block of copper as the anode. So impure block of copper as the anode, and pure thin strip or even a wire of copper as the anode, as the cathode, sorry. So reaction will be the same thing. CuSO4 will give you Cu2 plus SO4 2 minus, H2O will give you H plus and OH minus. So of course at the cathode, what is going to happen is the CuSO4 ka Cu2 plus is going to come at the cathode and going to get deposited on the cathode as Cu metal. So Cu plus 2 plus 2 electrons will give Cu and deposited. So Cu2 plus ions are discharged at the cathode as neutral copper atoms. Thus pure copper deposited on the thin sheet of pure copper placed at the cathode. So the thin sheet के ऊपर, pure thin sheet of copper के ऊपर pure copper उसके ऊपर coat होते जाएगा, and that's why the size of that cathode is going to keep on increasing, and the size of the anode will keep on decreasing, because what happens in anode will be Cu minus 2E will be Cu2 plus. So SO4 and OH migrates to the anode, but no discharge. Instead of that, the copper anode itself loses electrons to give copper ions in solution. Hence, anode diminishes in mass. So anode will keep on diminishing in mass, and it is going to get coated on the cathode. So the impure block of copper anode gets used up, and the impurities settle down. So at the end of the reaction, the complete copper यहाँ से जो है वो पूरा का पूरा transfer हो जाएगा on the cathode, and the impurities over there will settle down as anode mud. The pure copper metal dissolves out from the copper anode, an impure copper block, and the Cu ion formed in the solution at the anode are deposited at the cathode, that is on the thin pure sheet of copper, by gaining electrons. The impurities present in the impure copper anode settle down as anode mud or slime, which contains insoluble impurities like gold and silver. Impurities such as iron, zinc, etc. higher in the electrochemical series ionize and dissolve in the electrolytic copper sulfate solution. So that is what is happening to the impurities. And then the metals generally refined by electrolysis. So metals are extracted by electrolysis, that is high electropositive elements. Metals are already deposited in the cathode in the pure state, and hence need not be refined further. Zinc, lead, copper, mercury, silver are thus generally refined by electrolysis. So the one which are refined by electrolysis are zinc, lead, copper, mercury and silver, because the one which are above that in the electro reactivity series will need electrolysis for its general extraction of the metal, and that's why it does not require any refining to be done, because already जैसे aluminum के case में we are learned in metallurgy that aluminum के case में we are doing electrolysis to gain aluminum from the ore of the aluminum. That's why you don't need any refining to be done. So that is about the electro refining taking place by electrolysis. We now see the next part and the last part of the chapter, and that is electrometallurgy, process of extraction of metal by electrolysis. So this is of course by reference only, this is not required to be learned, but this same thing is already there in the metallurgy part. So that's why we just seen that see, it is such a way that whenever you have got a metal which is highly reactive in nature, it is very difficult to go for any chemical change, chemical reaction wherein we can remove the whatever addition is there to that metal. So metals, for example, if it is sodium, okay, sodium is going to form into its hydroxide very easily, sodium is going to connect with chlorine very easily or carbonate very easily, because it's very highly reactive in nature. So अगर मुझे sodium चाहिए, तो the only way I can extract sodium is by electrolysis. So electro refining will be electrolysis will be required to extract the sodium, potassium, calcium, magnesium, aluminium. All these are all these are the metals which are going to require electrolysis for their extraction. So the process, what is the process or the method by which we are extracting these metals from its ore is called as electrometallurgy. So electrometallurgy is the process by which the metallic ores metals are being extracted from their ores using electrolysis. So potassium, sodium, calcium, magnesium and aluminum by method of extraction is by electrolysis of their fused salts. For metals higher in electrochemical series, their oxides are highly stable. Metals have a strong affinity for oxygen, and on electrolysis, metal is deposited at the cathode. Hence, metals generally extracted by electrolysis are potassium, sodium, calcium, magnesium, and aluminium. So, for example, Al2O3 is a highly stable oxide of aluminium, has a strong affinity for oxygen. Hence, conventional reducing agents like carbon monoxide, hydrogen cannot reduce Al2O3 to Al, and hence Al is extracted by electrolysis. So examples is fused calcium chloride, NaCl will give you Na plus and Cl minus. So Na will be at cathode and Cl will be at anode. Fused calcium chloride, CaCl2, so Ca plus 2 and Cl minus 1. So Ca will be deposited at the cathode and Cl2 at the anode. Fused alumina, Al2O3, which will be Al3 plus and O2 minus. So Al will be everywhere at the cathode and oxygen at the anode. So this is how the electrometallurgy helps us to extract the metals from their ores, respective ores, like in case of NaCl, CaCl2 or alumina. Whereas the one which is zinc, iron, lead, hydrogen or copper, we can easily extract those by reducing agents, because their oxides are not so stable, they can easily be removed. So there we can use any reducing agent, and that reducing agent can easily reduce that metallic oxide into metal. So that's why by using reducing agents like carbon monoxide or hydrogen, their oxides are less stable, and reducing agent reduces metallic oxides to metals. For example, CuO plus C will give you Cu plus Co. Whereas the mercury and silver are those kinds of metals जहाँ का उसका oxides are totally unstable. यानी अगर metal मुझे oxide of mercury or oxide of silver is available to me, if I just heat it, the oxygen is going to run away. So in this case, but they are going to be extracted by thermal decomposition. So because their oxides are least stable, so heat alone can reduce metallic oxides to metals, and give us the requirement. So AgO will give you Ag, so Hg plus HgO will give you Hg plus O2. So this is how you are going to extract the metal. So method of extraction of metal depends on the position of the metal in the activity series. So that is about the electrometallurgy. And we can see the summary which is given over here about the different equations which are there for lead bromide and acidified water, copper sulfate, inactive copper, and then nickel, then silver for electroplating and electro refining copper. So these are the important things which are there in as a summary for this particular the electrolysis of different. So we have learned over here 6 different electrolysis taking place of lead bromide, water, acidified water. Copper we have got 2. One is for the active electrode and other one is the inert electrode. And then there is nickel, silver and copper refining. So these are the different things about the chapter. So yeah, this is the end of the chapter electrolysis. Okay, there were 5 parts of this. Quite a simple thing, right? So initial part, if you understand it properly about the differentiation, preferential discharge and selective discharge, then the things becomes quite easy. Yes, you need to learn the equations over here, all the equations of this part, what happens at the anode. So reactions at cathode, reactions at the anode, the ions which are migrating at the anode and cathode, the overall reaction of dissociation. All these are very, very important. You also need to know that what is the temperature at which certain things is taking place, what is the current taking place, and what is the crucible to take over you are going to take for the electrolytic cells. So all these are important parts of the chapter. So just go through them properly and learn them properly. Yeah, that is all about the chapter electrolysis. Thank you.